Okay, so we have central angles and inscribed angles. So on the back of your worksheet, let's go ahead and take a look at central angles first. Now central does have the word center in it, right? That's central. So a central angle is going to be an angle that actually is somewhere, it starts somewhere in the center of your circle. Now it can really go any direction, but this is going to be a central angle. And I am going to use that abbreviation for angle just to make it easier. Now a central angle, we do name it by its 3 points. Let's do M, N, O. So in this case, my central angle is going to be angle M, N, O. And notice that the N is in the middle. Since the N is in the middle, it is this angle right here. The second piece of information that we always want to know about central angles is they do make what we call an arc. Marco, you want to pick up the paper and turn in your phone, please? It makes what we call an arc. And you did name arcs last week. Arcs are the part of the circle, the outer edge, that circumference of the circle that is within the endpoints of our angle. So in this case, we do have an arc, and we call it MO. It is a minor arc. It is less than half the circle, and we mark an arc with that curve over the top. Okay. Now, the important things about central angles in arcs is they do have measures. They do have measures. We do measure them by degrees. And you guys are familiar with an angle measure. So say that this is, let's say, 60 degrees. Okay. So in this case, angle MNO is equal to 60 degrees. Well, a circle on the inside here for angles is always going to be equal to 360. Same with the degrees of the circle on the outside. So the degrees of the arc all the way around is also 360 degrees. Good morning, Lucero. You want to pick up your packet? Now, when you have a central angle, the arc is actually exactly the same. So in this case, our arc is also 60 degrees. Now, 60 degrees is just the amount of direction that this arc takes. It's about the part of the entire circumference. Notice it's not in feet, it's not in centimeters, it's in degrees, because an entire circle is 360 degrees. Now this arc, MO, is also 60 degrees. So the cool rule here is if you know your central angle measure, it is 60 degrees, then you know that your arc is also 60 degrees. Good morning, Gio. You want to drop off your phone and pick up a packet, please? So your central angle is equal to its own arc. So you're going to come up with math problems that are going to give you the arc, 75 degrees, and they're going to ask you what the central angle is. And you're going to say 75 degrees. Okay. So let's, what we're going to do, I'm going to pause for a moment so you guys can catch up. If you're watching the video, you can zoom ahead to where I start talking again. I have to give them notes. You guys good with this piece? I'm going to teach you the next piece and then we'll go do some practice. Okay, so now what we're going to do is we're going to look at our inscribed angles. Inscribed angles, I'm going to put inscribed here. Inscribed angle. An inscribed angle is on the inside or takes up the entire inside of the circle. So it does start on one edge of the circle and then the angle takes up the inside of the circle. So let's name this one ABC. A, B, C. Now we do have the angle of ABC. And we also do have an arc here. we have arc AC. Right? So if you can see here, we have our arc. Okay, there's our arc. Now our angle, ABC, is this angle right here. Right? Now this one gets a little bit trickier. If I have an inscribed angle and it has a measure of, let's say it has a measure of 40. The arc angle is actually going to be 80. What's the relationship between 40 and 80? Anyone have an idea? It's half or twice as many, right? So our inscribed angle, this smaller angle way up here, is going to be half the size of the arc. Or we could say the other way around. The arc is 2 times the angle. So we're going to go ahead and write that over here. So we have 2 different ways to write this. Okay, way number 1. We know that the angle is going to be equal to half of the arc. You know what? Let me go ahead and let's go back and do this. Let's make it generic first. Okay. So your inscribed angle is half of the arc. So if I know the arc, I cut it in half and I have the angle. And vice versa. If I have the arc, it is the same thing as 2 times the inscribed angle. Now I'll kind of show you what this means. I'll show you in 2 different ways. I know I'll give you guys time to catch up on the writing. Now the key to this is always understanding when you have arcs and when you have angles. Angles will always have this angle side. Okay. Your arc, actually in this case I used orange, your arc is going to have the curve here. So recognizing an arc versus an angle when they give you measurements. So I know that my inscribed angle, so let's go ahead and put our inscribed angle. So here's example number 1. My inscribed angle is angle ABC. I know it's equal to half of the arc, and the arc is AC. Okay. If you notice, I brought my angle here, and it is equal to half of the arc, right? Half of the arc. Now I can plug this in and prove it. My angle is 40 degrees. Then I'm going to use my 1/2, and my arc is 80 degrees. Okay. Melissa, if you can close your laptop, please. I need you to be taking notes. Thank you. Now notice that 40 stays 40. Half of 80, and if you need to on your calculator, you can find half of 80. 80 divided by 2. Or you could even do 1/2 times 80, and you're going to get 40. So as you can see, this equation works. Now the other way we can do this, because you're going to have to choose. You're going to choose what formula works for you. I can also do my arc. I know that AC is equal to 2 times angle ABC. My arc AC, if I come out here, my arc AC is 80 degrees. I keep my numbers. My angle ABC is 40 degrees. And when I solve that, I get 2 times 40, which we know already is 80, and it works. Now, as I go to explain some of this, we're going to do some practice problems. I do actually have it up there on the poster as well, or you can keep kind of flipping this over and taking a look at it. So when we go to solve this problem, you're going to kind of take these steps. I wrote them on the poster. I don't know if you guys can see it all the way back there. But first of all, you want to figure out what type of angle you have. Is it central or is it inscribed? Then what is the relationship? Central angles are equal to arcs. Inscribed angles are equal to half the arc. And technically you have 2 here. Okay, so we're going to, each time that we look at a problem, we're going to ask ourselves these 2 questions. So you can figure out what you're going to set up. I still have a couple people writing. Okay, Gia, we'll get you. You got it, Gia? Okay, so lesson 3 on the front. So the key is, well, we can, I mean, definitely if we read it, we know what we have, but already we can take a look at what is our angle here. Do we have a central angle or an inscribed angle? We have inscribed, right? It's taking up the inside of the circle. So now, first thing we got to do, we've figured out we have an inscribed circle. Now we're going to look at what is the relationship and fill in information. In circle P, so remember we name circles after their center points. In circle P, with the measure of minor arc NQ equaling 48 degrees. I'm going to label that NQ. Notice that this is an arc. So I'm going to go ahead and put arc right here, right? And it tells me the arc is 48 degrees. So I've taken my givens, minor arc NQ is 48, and I've labeled my picture. Now it asks me to find the measure. Remember, that M means measure. Find the measure of angle NRQ. Okay, angle NRQ. NRQ. They want me to find this measurement right here. So I am going to go ahead and put an X. What is that measurement? Now, since this is an inscribed angle, we have 2 options. I'm going to turn my paper over. We have these 2. We can either take our inscribed angle and our arc and multiply, or divide the arc by 2. Or we can take our arc. In order to find our arc, we multiply our inscribed angle by 2. Now, I know that seems like a lot of words. You're like, I have no idea what I'm going to do. So let's go ahead and find out what we have. We have an arc of 48 degrees. Is it easier to plug in the arc and divide by 2? Or put in our arc here? So I have to figure out where do I want to put my number and which one's going to be easier. I'm looking for my inscribed angle. That's what I want. So I'm going to use this first one. So on here, in order to find my arc of NRQ, that's what I want. So I'm going to plug in what I know. It's going to be half of the arc, which is NQ. So I know now my angle NRQ is going to be half of 48. Since this is 48, I can plug in 48. Okay. Now I'm just going to solve it. What is half of 48? Well, you've got 2 ways to do this. You can do 48 divided by 2, because that's half, right? Or if you want to go the long route, you can do 1/2, write in 1/2, and then times it by 48. But notice you still get 24. So in this case, our angle NRQ is 24 degrees. Now, some of you in your mind might be like, okay, well, if this is 48, I just know half is 24. That's the answer. Okay, let's take a look at number 2. Number 2, we have another angle here, and I first have to decide what kind do I have. Does it start in the center or does it go across the whole circle? It goes across the whole circle. So what kind of angle do we have here? Any questions? We have central or inscribed here. Okay, if you're thinking inscribed, you're right. Okay, so we do have an inscribed circle. Since we have an inscribed circle, I'm now going to go ahead and read. It says in circle L, remember, that's circle L, with measure of angle KNM equal to 15. So this time, they've actually given us the angle measure. That angle measure right here, they've told us it is 15 degrees. And if you need to draw an arrow, it is 15 degrees. They want us to find the measure of the minor arc KM. They want us to find this measure out here. So I'm going to go ahead and put X. That's what I don't know. Now in this one, they have given me the angle measure. So I'm going to turn over here. They have given me the angle measure. I'm looking for the arc. I want to know the arc. Since I'm looking for the arc, I'm going to use the second one. It actually doesn't matter. That just works for me. You can decide what works for you. Since I want the arc, I'm going to use the second one. And so I know that the arc, so what is that? Arc MN, no, MK, is going to be 2 times, remember it says right here, is 2 times the inscribed angle. Is going to be 2 times angle KNM. The arc is 2 times the angle. So in this case, MK is going to be equal to 2 times the angle measure of KNM is 15 degrees. KNM, MK.
It's KN minor of KN.
Oh, you know what? Technically, I can go either way, remember? Yeah, I can sit and name it either way. But good catch. Yes, you can totally do KM. Because in this case, we just want to know the name of that arc. This one, you know what? You're right. Most of the time, order matters. This is the one time it doesn't. But it's okay. You can stick with order matters and keep it the same. Okay, so we'll switch it. It is KM is equal to 2 times 15. 2 times 15 is, and if you need your calculator, 2 times 15 is 30. 30 degrees. And that is our answer. Now I get to tell you guys we did the hard ones first. Inscribed angles are a little bit harder because you have to plug them into an equation here. Okay. But let's jump down to number 3. Number 3, do we have an inscribed or a central angle here? This one is central because it starts at the center of the circle. These are the cool ones because central angles are the same as their own arcs. Okay, so in the circle T, with the measure of angle STU equal to 134, so STU is 134 degrees. Find the measure of minor arc SU. So they want us to find this one. That is our X. But the cool thing about central angles is that angle STU is going to be equal to the arc of SU. So if this is 134, then so is arc SU. Don't need a calculator for that one. So if this is 134, then this is 134. Now, if you have that, let's go ahead and let you work on 4, 5, and 6, and I will come around and kind of just check in on you as you work on 4, 5, and 6.